welcome to your first MTE lab and course. In this video, I will be showing you guys how to set up your lab environment, as well as giving you tips on how to be successful in this course. Now, all of you guys have taken a previous programming course called CPS 188, and some of you guys might have not done your best or might have not even understood the course content, which is completely fine. Some of you guys might have even gambled the course, which is totally okay, because in this course, everything is built on top of it. And now you guys might be wondering, how is that gonna help me? But in MTE301, everything that you've learned in CPS 188 is constantly gonna be repeated. In every single lab you do, and every single code you write, everything you've learned in there will be repeated and it will be pieced together. So you get to see the full vision of everything working together. And because you constantly repeat it, you will naturally just get the flow and understand it clearer and better. And because it repeats so much, it will just naturally come to you. So don't stress, don't worry, you guys will be completely fine, okay? And before I start the actual setup, now I want you guys to know that this isn't your last programming class. Yes, it's your last focused programming class, but you will be taking more courses where you will be learning other languages, but the full course wouldn't only be on the programming aspect, it will also be on the hardware. For example, MTE301, microprocessor systems. In that course, you will learn the language assembly, as well as the hardware of microcontroller system and whatsoever, and you will be using C++. This course is a foundational course for every other software or any other MTE course to come. So it's important for you to at least try this course. If you can't do your best, at least attempt to understand it, because it will help you in the future. So let's actually begin this presentation, okay? Before we actually start installing Ubuntu, you might be wondering, what is Ubuntu? Okay, Ubuntu is a version of Linux. And what is Linux? Linux is an operating system that's on steroids. It's similar to Windows or Mac OS. Linux allows you to modify things. It allows more access for you to custom things and cater towards what you're building, which is essential for engineers, right? As engineers, you want access backhand and fronthand. You want to make changes to everything, and Linux allows you to do that. And it's really important for this course and important for you guys to know what Linux is, because as engineers, you will be using Linux a lot. And it is a really important tool to use. And in this course specifically, we won't be going too much in detail about Linux itself. We're going to be using the very basics of Linux to do our labs. So how will the labs work with Linux? Essentially, you will be streaming Linux using Ubuntu, which is a version of Linux, and then you will be streaming a copy of lab templates that your TA made. You're going to be making copies of all those folders and templates, and you will be opening them via Linux, right? And Linux will open it using VScode, and then you will be using commands to actually run and compile your code. And you guys might be like, how does that work, right? Don't worry, don't stress. I'll show you how it works, okay? We'll do it together. I already explained how labs will work, okay? You will essentially be given a template and you will just be filling out the blanks. You don't need to worry about graphics and whatever. You just need to worry about the logic of your robot for that specific lab, okay? We're just making copies of folders or copies of templates, and you're just working on one file, a C++ file that has a template, and you're filling in the blanks with your logic. Nothing too complicated. Well, it will get complicated, but it's not too complicated, okay? Let's begin our actual lab setup. Now, how do we install Ubuntu? Now, I'm gonna be showing you on my screen how to install Ubuntu. And just follow my steps. The steps are also on the slides. I'll also have this slide presenting as I install Ubuntu on my computer. I'm currently in Care Hall East 137, the MIME computer lab. You guys will be having your labs here too. And it's important for you guys to know that use the same computer whenever you're doing your lab, because your work will be saved onto that specific computer, and Ubuntu will only be installed in the computer you install it on. So if you log into another computer, Ubuntu won't be there. So make sure to use the same computer. I'm using computer number 6 and in Care Hall East 137. You might be in this classroom, or you might be in Care Hall East 118, which is the other MIME computer lab at the very corner in front of Grace's office. So our first step is to open our terminal, okay? You can search up terminal down here too. Terminal and launch your terminal. Now, let me move this here so you guys can see the slides. Okay. We are gonna type in the command WSL -- install. Now it's gonna install Ubuntu for us. And you can see it's currently installing. Okay, it's successfully been downloaded. Now you're gonna close your terminal, your Windows terminal, exit out of it, and now you're gonna search up Ubuntu. And here you go. This wasn't here before, you just installed it. Open it up. I'm gonna put it here so it's clear to see. Now, it's gonna ask you to create a user account. It gave me one username by default, so I'm gonna stick to it. You guys can make whatever you want. Now it's gonna ask you to create a password. I will write my password, but it won't show you guys because it keeps it confidential. So your cursor is not gonna move whatever, but you can type, but it's reading what you're typing. And I press enter, and now it's gonna ask me to retype my password. I retype my password, and boom. You are now in the Linux environment. Now, before we actually start creating a copy of the files that your TA created, or your professor, we need to install the necessary libraries. Okay, in the slides, you can see there are 3 libraries we need to install. You can copy and paste these libraries directly, like the commands. These are the commands to install libraries. I'm presenting, so I can't copy from here, but I've also created a separate doc that has steps on how to install Ubuntu. So I'm gonna just copy and paste it from here. So you're gonna, don't copy the dash. You guys have access to this too, by the way. It's all in the database. I'm gonna copy this. I'll paste it on here. I'm gonna hit enter. It's gonna ask for your password. Enter your password that you just created. Click enter. And now it's installing that library for you. It's 92%, 99, whatever. Okay. It's installing. Okay. Now it's successfully installed that library. Let's install the next one. Copy it, paste it, and it's gonna ask you, do you wanna continue? Y and /n for no. Just do uppercase Y, cause yes. I can copy the next one while it's installing. Make sure to not copy that dash. Okay. Now we can install the third one. The second you see this green thingy with your username, okay, it's done installing. It's gonna ask me YN. I go, yeah. It's installing the third one. Okay, now we have successfully installed all the required packages and libraries we need for our labs. Now it's time to make a copy of the folders that our TA created. Our TA, your TA probably used GitHub to make copies. No. Let me reword that. All the folders are located in GitHub, and there's a command where you can copy all the files from GitHub using a link that your TA will give you, and it's in your lab manual. I have it also here too. If in case it changes, I will be updating this page for you guys, so don't stress. Okay, just copy, don't copy the dash, this git clone with this link, and now you paste it here. Now you could see that it's cloning. Now it's going into GitHub, it's making copies of every single file, organizing them in the correct folders onto into your Linux/Ubuntu environments. And now it's asking me for my username. This is because it's currently the summer semester and the TA has locked access into GitHub, and he's removed it completely. So I don't have access anymore, but I still have a version of it installed, and I have it on another computer, on the computer right next to me in the same lab. So I'm now going to be shifting everything into another computer where I'll show you the next steps to after you've created your a clone of all the files. Okay, I'm now on another computer where I already made copies of the folder before the TA locked access for me, and now I'm going to show you guys how to access and open up the correct folders for your lab. Now here are all the commands in the slides that you need to know. There's also a separate document, okay, where I've listed out all the commands you should know, and if you don't, or extra commands too that you can use in case you mess up something or you want to have fun. Okay, now the main commands we're going to use are ls. That shows the files and folders in the current location, shows you all the folders Ubuntu currently has access to. That's ls. cd moves you into that specific folder, so you would write cd and then the folder name, and that will take you inside that folder. And then from there, you can go deeper into another file if you wanted to, or into another folder using cd again. Now I'll show you how I'll just show you how it works, okay? Right now I'm gonna put in ls to see what Ubuntu currently has access to. Now you see these blue lines? I mean, not blue lines, these blue files. These are all files. So apparently I have two files right now, MTE301 lab and MTE301 lab 2. Ignore MTE301 lab 2. I made a copy of this because I kept on messing up this lab, okay? You guys just focus on MTE301 lab. This is your general lab. It's your big folder, and there are folders inside of it that are labeled lab 1, lab 2, lab 3, lab 4, lab 5. So now you're gonna use your command cd to open up that folder. So cd, now enter the folder name. It's MTE301 underscore lab, and make sure to follow the right, use the right letters, right numbers, right cases, and whatever. Okay, it wants it exactly how it says when you put in ls. Okay, now here right next to my name and what computer I'm in, it says MTE301 underscore lab $sign in blue. That means I'm currently in that folder. What do I do now? Now that you're in the folder, you can type in ls again to see what folders are inside the current folder you're in. And you see there's lab 1, lab 2, lab 3, lab 4, lab 5, and all these other files. Let's open up lab 1 because you guys most likely working on lab 1. cd lab 1. And now you could see it's added lab 1 here right next to MTE301 lab. Now from here, in order to launch our code and see what the files are, you're going to use the command code dot. And now it's going to open up VScode, and there you go. This is your lab 1, and it has all the necessary files you need to run lab 1. Okay, and as you can see, I'll make this bigger right now so you guys can see. Most of the code is already done for you. You are just to define any local variables here, write your code here. You were to just write the logic for each corresponding task. It's very simple, guys. Okay, and whenever you're making edits to your code, remember to use Control S. Okay, use Control S every time. You need to save what you're doing so that Ubuntu updates the changes you've currently made to your code. If you don't use Control S, it's not going to update, and then your code's going to be stuck. It's going to be stuck at the template. It's not going to think you updated anything, and it's only going to compile the template, which will spit out an error for you. Okay. Now read the lab manual, figure out what you need to do. Okay. And then we'll move on from there. Now that, let's say we've made changes to our lab and whatever, okay? You updated it by holding Control S, and you've saved all the changes. Now, how do you compile it? You are not supposed to compile using VScode. You are to use Ubuntu. And I'll be showing you guys how that works, okay? Go here for a second. How to run and compile your code. Okay. Right now, because I don't have my code for lab 1, I'm going to go back. I have the code for lab 4, so I'm going to be showing you an example using lab 4. So don't worry. Okay. I'll be showing you guys how to compile your code. So I'm going to put in cd MTE301 _lab. Okay, to access my lab folder again. Now I'm gonna put cd lab 4. I'm not using ls because I know what files are contained in what folder, so I don't need to use ls. You can use ls to see what files you have. I just have them memorized. Lab 4. Now I'm in lab 4. I can close this existing VS Code because I will be opening up a new VS Code. I will type in code dot, and now here you go. And you're gonna be seeing a bunch of folders, right? The only folders you are to make edits to is the lab4.cpp, okay? This is the only file you should be making edits to. You shouldn't be making any edits to any other folder. If you are, file, you are making a mistake, and there's another way to actually do your lab, okay? And let's say I already did lab 4 and I want to compile it. How do you compile it? First, after making your changes, I'm telling you this again. It's very important. Hit Control S to save your work, and so that Linux knows that you've made changes to your file. Okay? You are going to be using the command make to compile. Type in make space, and you're going to see G++, this, that, whatever, and now it's compiling your code. Now to actually launch and run the code, okay, we use the command // and whatever the file name is. In this case, it's lab4, so I'm gonna put /lab4. And it's a lowercase l, make sure you use lowercase. I'm gonna hit enter, and there you go. This is lab4. I believe it's task 1. Okay, so that's how you compile your code. Here's the thing. Every lab has more than one task, and you would need to rewrite the code several times, right, for every single task. And you should ask your TA how they want you actually to structure and organize your separate tasks. Do they want them in one single main file, or do they want several different CPP files and whatsoever? Me personally, what I did was that I created a new file. I called it task1, okay, .cpp, because it's C++ file, it's code, right? And I would copy the template from the main lab, whatever you're in. I would copy the entire template, and I would just paste it into task1.cpp. But here's the problem. When you go and you use the command make, what happens is that it would only compile lab4.cpp because your maker file is only programmed to run lab4.cpp. And you're not supposed to be making changes to any of your files but that main lab whatever you're in.cpp. So in that situation, you weren't able to compile those files individually. So I made a solution up for you guys where you can manually compile every task individually. There is in our database, and we'll try to get your professor or TA to upload this too. We created a cheat sheet essentially where you can name your new files task1, task2, whatever .cpp, and we've given you the manual way to compile every single code and launch and run it for you. Okay, so you don't need to worry about figuring out how to compile it individually. You could just copy this, paste it onto your terminal, and it will compile and run for you. So here, okay, I'm gonna go to my lab4.cpp. I'm gonna copy everything in this file, okay? Imagine this is the template. The code is not done, okay? Whatever. I'll paste it on here, okay? And then I will write my entire logic for task 1. And then I'll make a new file, copy the template, and make a new logic for task two and whatever. And in order to run it, right, you can't use the command make anymore. You have to manually compile them individually. And you can do it by using these commands that I have made for you guys. Okay. Okay. You copy and you just paste. Click enter. Undefined reference to the main. You guys want to know what happened and why it didn't work? I forgot to hit Control S. That's how important it is. You have to always save your file. Okay? Control S. Now I'm gonna type in the command again. You can also use your keys, your arrow keys. You can use the up one to see what command you put in previously, and you can use the down key to see the last one you just used. Okay, so here was the command, okay, to compile /task1, and there you go. Now it's running task 1, and let's say I created another file, okay, called task2.cpp. task2.cpp. You could create another file, task2.cpp. Make sure to use lowercase t because the commands we've made here for you guys are all in lowercase. And you could just simply go to task2 here, copy and paste it here. Okay. Now if I go back to the slides, okay. Now how to save and submit your work. Okay. You can use the command pwd. Okay, and it will tell you exactly where the current folder is located. Okay, it says it's at home. It's inside MTE301 and Lab 4. So what will I do? I will go into my file explorer. Okay, I will go into Linux, go into Ubuntu. I will search up. You can also do this Lab 4. Lab 4. And it's gonna take some time, okay? I'll let it do its thing, okay? Some important things to note before I end this presentation. The MCU database has a lot of resources to help you do well in MTE301 as well as other MTE courses. We are a new course union, right? We are currently talking to professors and we're coming up with resources to help you guys be successful. We're also planning a bunch of upcoming events for this upcoming year and the upcoming semesters. So follow us on Instagram. Stay tuned for updates about mocks, events, and whatsoever. Okay, because we have big things planned and a lot of collabs. Just stay tuned Follow us on IG. Stay tuned for your updates. If you have any questions, you can reach out to us using our email, tmutron@gmail.com. And a tip for you guys is to use W3 Schools for practice, okay? If you did not do well in CPS 188, it's completely fine. Use W3 Schools and learn C++ and Python. Use that. Do the basic exercises you need to do to understand everything. I know a person, his name is Patrick Christina. This guy, after every single set in the gym, this guy goes to his iPad and he starts solving integrals. You guys should be doing the same, but instead you should be doing a few reps of W3 Schools, whether it's on your phone or whatever. At least read it, understand it, and then do it later, okay? You should be using this for easy reps. This will help you get a head start and understand things clearly, okay? It's an excellent resource. Also in our database, we have, let me go back. We also have midterm practice questions, okay? A problem set full of a bunch of questions you can practice before your midterm, okay? And they're separated into 4 different parts. They're long answer questions, they're coding questions, and their solutions all posted too, okay? Use this, okay? Do a few. Don't do all of them if you don't want to, but at least attempt to do a few questions from this problem set. This will help you, and I promise you, it will at least get you a 50 in the course if you attempt a few questions, okay? Because you can expect questions along the same lines, okay? Let's go back into saving our folder. I'm jumping back and forth, but our lab 4, okay, it finally found lab 4. What you're gonna do is just simply copy it, move it to downloads or somewhere it's easily accessible, okay? Put it into desktop, why not? And we'll put in documents. Paste it, and now you have lab 4 here. From here, you can compress all of these files, hit this, compress the zip file. Now compress it to a zip file, you can name it MTE301 lab 4 zip. And now you can submit it.